So now, once you do this out, then we can do the RMSE. Oh, and just let me say here also, this is a 5, so that's clipped, and this is a 1, that's also clipped. So you can do that out. You can see from D2, for instance, D, that's going to go below because 2 minus 1.5 minus 1.17 is already actually a negative number. It's below 0 even, so we just clip that at 1. So now the RMSE, we'll do the RMSE of the test set. I'm just going to do it. I'm not going to do every step out this time. I'm just going to do it all in one single step. So again, we do the square root, and then we have to find the mean of the squared errors. So now we'll write out these squared errors terms. So we have 4 and 2.80. So this is 4 minus 2.80 squared, plus, now the second one, this is 2 minus 1 squared, plus, in the third one we have 5 minus 5 squared, which is just 0, because 5 minus 5 is 0. The fourth one we have 3 minus 3.5 squared. And then the fifth one, it's kind of running out of room over here, but now the fifth one we have 4 minus 3.85 squared. And we divide that by 5 because we're averaging everything. So I'm going to write out just what each of these terms are when we square them in here. We get, this is 1.44. This is 1 clearly because 2 minus 1 is 1. 1 squared is just 1. We have 0, as we said. We have a 0.25. And we have a 0.0225. That's all divided by 5 to average it, and then we take the square root of the whole thing. And then that, when we do that out, we get 0.7365. That's the RMSE for the test set. If we do the training set, we will get 0.4709. And I won't do that out again because there's 20 of those terms, which would be a lot to write on paper, but that's the idea. So now we can compare this with the RMSE that we had before, and so now we have an improvement. If we do an improvement over that 1.0247, which is what we had before the RMSE, the test set, just when we did the raw averaging, we're down to 0.7365 now. So if we want to find the percent improvement over that, we just do, we start at 1 because everything is starts at 100%. So we're trying to find the percent improvement. So basically what we're going to do is we're going to find out what fraction we are of that right now. So 0.7365 is where we are now, and we were at 1.0247, right? And so we do 1 minus that because we're trying to find the percent improvement. So the lower that we are relative to this, the better. And we multiply that by 100%, and we get 28.13%. So we're improved almost 30% over what we had before. And for this guy, the improvement's actually more like 59%. So you can see that again, we did much better than we did when we just did a simple raw average. And so that's somewhat explaining the utility of using this approach. But know that the percentage improvements are going to be way different depending upon what example. This is only one example. And in fact, the improvement could be negative, in which case we're actually getting worse. So it's not always guaranteed that we're going to be getting better, especially if there's some unknown patterns in the data. But on average, we expect intuitively that incorporating this is going to make our prediction better.